at this forum. And my apologies for intruding in this session. In fact, I should have spoken in session 4 on oceans, but because of some urgency, I had to return today itself. So Sudarshana was kind enough to shift allow me to intrude in this session. So I'm not going to talk on the Arctic or Antarctic. Being a ocean science person, I'm going to talk on oceans. So you will be listening little different from what the previous speakers have spoken. So it is very unequivocal that our climate is changing. The entire Earth system is warming, especially the oceans and atmosphere. Except for few people in North America, they are not convinced that the climate change is happening. So if you look at where this heat is getting accumulated, and if you look from the AR5 2013 IPCC report, you find that the 93% of the heat is getting accumulated in the ocean, and only 3% goes in glacier melt. That itself is alarming, as we heard from the other speakers. The Arctic ice is more than 40% of the ice is getting melted, and 3% goes to soil, and 1% goes to the atmosphere. The ocean is important because 96% of the living space on the Earth is in the oceans. It has 80% of Earth's living organisms. We are only 20% on the land, other 80% is in the ocean, and covers 71% of the Earth. Almost half of the oxygen we breathe is produced by ocean plants. So 50% of our oxygen in the atmosphere comes from the ocean. And fish provide 4.2 billion people. Its total population is about 6.5 billion. So large population is supported by the fish from the ocean. And 90% of the world trade is depending on the oceans, and holds an estimated 80% of Earth's mineral resources. So ocean is very important for all of us, for our survival of the entire humankind. And if in a warmer world, what's going to happen is observed increase in ocean atmospheric carbon dioxide, and observed changes in the physical properties of the ocean. Because the ocean is warming, the physical properties of the ocean is changing, and as an effect, the marine biogeochemical cycle in the ocean also is getting or going to change. These are coupled systems, so one after other these effects are going to take place. And increase in atmospheric carbon dioxide, additional carbon dioxide, because the atmosphere has excess carbon dioxide, it gets dissolved in the ocean, and that changes the temperature and salinity of the ocean. And as the temperature and salinity changes, the solubility of the ocean water changes, and the chemical equilibrium starts getting disturbed, and changes in circulation of the ocean because the mass balance gets disturbed, and supply of carbon and the nutrients from below, ventilation of oxygen depleted waters, downward penetration of anthropogenic carbon. All these are cyclic processes, and it's happening in the ocean. And ocean stratification affects the marine productivity. The productivity gets affected, and the mixing between the surface and deeper waters gets affected. Length of the growing season because of the change in the mass balance, and general environmental condition itself gets changed. So if you look at the first and foremost effect when we talk about the climate change and the oceans is the sea level change, and it is unequivocal that the sea level is increasing at a rate of something like right now it is about 3 millimeter per year, or 1.7 to 3 millimeter per year. It is keep on increasing, or it is very likely that the mean rate was 1.7 between earlier, and now it has increased to 3.2 millimeter per year, and this is from the IPCC report itself. And my colleague Devi and his team has looked at the Indonesian change, and it is at a much much higher rate. And also they find that there are some decadal changes also is happening in the Indian Ocean sea level. And if you analyze the sea level data from the tide gauges existed all along the Indian coast, you can see that this kind of changes have happened. Or on an average, even along the Indian coast, about 1.7 millimeter per year, that is the kind of sea level change is happening all along the Indian coast. And also the research shows that the Indian Ocean is warming at a much faster rate in the recent years than compared to the other oceans or the Pacific and Atlantic. So that means the Indian Ocean is gathering more heat, or at a much accelerated rate the Indian Ocean is warming, and that is true. But the paradox is that this heat is not coming from the atmosphere alone. If you look at the atmospheric fluxes, in fact, there is a downward trend, or the atmosphere is inputting the heat in the Indian Ocean at a lesser rate, but the sea surface temperature or the Indian Ocean is warming at a much higher rate. There are several hypotheses has been put forward, and if you look at this graph which I had taken from one of the published literature, Veronica et al. From the Science, you can see that this is the portion of Indian Ocean, the leftmost, and this is the portion of Pacific Ocean. And if you see that this is for 1993 to 2002, and from 2003 to 2012, you can see that the Pacific, which was red earlier, which is becoming, and Indian Ocean was blue. That means more heat was there in the Pacific, and Indian Ocean had a lesser heat. And now the Pacific that slowly turning towards blue, and Indian Ocean is becoming warmer and warmer. And then another research paper which says that through the Indian Ocean through flow, a lot of heat is getting accumulated into the Indian Ocean. And it is true that the heat is getting accumulated in the Indian Ocean. And another study by Rahul and Ganeshwaran, they say that the westerly winds over the Indian Ocean are becoming stronger and stronger. So the westerly winds, they will suppress the upwelling on the equator, and push the thermocline down, so you can have more warmer surface. This is another hypothesis. And another hypothesis by some of my colleagues, which they have looked at the meridional circulation. What they find is that this is becoming stronger. So more warmer water from the south is being pumped into the northern side, and the southern flow is getting accelerated. So more surface water is being removed towards south. So this is making the northern part more warmer and warmer. And from the Indian Ocean through flow, the warmer water is coming in the deeper layers of southern ocean, and it is getting circulated over to the northern Indian Ocean also. Whatever it may be, there are effects. One of the studies shows, the Wang et al., it shows that the cyclones in the Arabian Sea before the monsoon, their intensities keep on increasing. So we have more intense cyclones which are developing in the Indian Ocean, which was not the case a few decades back. So that is one this. And some of the study what we have conducted, it shows that the depressions over the Bay of Bengal, because the depressions are very crucial for the rains in the central and the northern parts of India. These depressions are, the number of depressions forming over the Bay of Bengal are keep on decreasing. There is a clear decreasing trend in that. So there are effects because of this warming happening of the Indian Ocean. And also Dr. Rajivan and his colleague analyzed some of this rainfall data, and they also show that when the northwest part of the India, the rainfall pattern is, or the monsoonal rainfall pattern is increasing, the other parts, some of the other parts, this part as well as the southwestern part, the rainfall is decreasing, or lesser monsoon in those parts, and some other part the monsoon is getting more vigorous or more this. Similarly, one effect of this warming has been proved or shown is that the chlorophyll or the ocean productivity, that is slowly decreasing over the North Indian Ocean. And this has been shown by Roxy et al. That the productivities keep on decreasing. And another effect is that the oxygen is getting depleted in the ocean. So as this map shows, even our oceans or the Indian Ocean and as well as the Pacific, these regions are getting depleted in the ocean in oxygen, and slowly the oxygen is getting depleted in these oceans. The oxygen is getting depleted because the upper water column, the biological consumption, because the warmer water, more phytoplankton grows, and it gets it depletes this oxygen. Then deeper oceanic overturning slow down, and biological consumption increases, and basin scale multi-decadal variability. So all these factors are playing together in depleting the oxygen in the ocean. And as if the business is as usual and keep on warming, the IPCC says that we will end up somewhere. These are different scenarios. They show that right now we are somewhere here, but we may end up somewhere here as over 100 years or so if the business is as usual. But the good part is that these are all based on certain models. And if you, good part means we can still believe that, because we try to believe that that will not happen, even if it is going to happen or that is imminent to happen. These models have large errors, and even some of them has different, just 1 minute, different signs even. So there are uncertainties involved, though the observation shows that the oxygen is getting depleted. But the projections, we still have large errors in projecting this. And also there are several coastal areas where these reports are there. Even along the Indian coast, this low oxygen zones have formed, or they are forming, and they are strengthening. So, this schematic which shows that why that oxygen is. One major cause has been identified is because a lot of phosphorus and nitrate which is coming into the ocean, maybe through the fertilizers or from the sewage and those kind of anthropogenic effects, and that is increasing the productivity, consuming more of oxygen in those waters, and it's turning anoxic. So the solution is that we have to keep on observing and also use the models, and there should be a continuous interaction between the observations and the models to settle this issue or to bring down this error margins. So you have to use different type of observing systems, Argo floats. Now we have increased our Argo floats numbers so that we can get more observations on oxygen and other factors. If we continue this same business, right now we are here, and we may go to the business as usual, we may go somewhere here, and the water will turn to be more and more acidic, and less oxygen, more acidic. And the Paris Agreement, if everybody follows strictly, we can end up somewhere here. And if depending on the commitments which the countries have given, we may end up somewhere here. So the scenarios are not very good. And this is the rule now, or the SDGs. So 17 SDGs to transform our world by 2030. There are 17 SDGs, and 14 is pertaining to the life under the water or for the oceans. And these are the rules which are being put forward by all the countries to reduce the issue. And if we are to sustain, we should have if you draw 3 circles, because our interests are, one is environment, other one is economics and social, and you cannot separate these 3. And if you draw these 3 circles of equal diameter, and unless they overlap each other, we cannot sustain. If one of them grows bigger, then there are problems, and this balance will get disturbed. So we have to see that the environment, economics, as well as the societal or the social requirements, these all three balance together and work in tandem for a sustainable world. And this is what we have to aim for. Thank you.